Hello! This will be a demonstration of Proposition 23 from Book 6 of Euclid's Elements, which says that equiangular parallelograms have to one another a ratio compounded of the ratios of their sides. We're given two parallelograms, AC and CF. That AC and CF, such that the angle BCD right here is equal to the angle ECG right here. And we're going to put the two straight lines, BC and CG, in a straight line with one another, from which it will follow that DC and CE are in a straight line with one another. I explained this in my video on Proposition 614, so I'm not going to go through it again, but granted that BC and CG are in a straight line with one another, it follows that DC and CE are in a straight line with one another. And what we're going to prove is that these two parallelograms, AC and CF, have a ratio to one another that is compounded of the ratios of their sides, namely that the parallelogram AC to CF is a ratio compounded of the ratios BC to CG and DC to CE. Now, we're going to complete the parallelogram DG by postulate 2, right? So we're just going to produce AD out in that direction, and we're going to produce FG upwards. So we're going to have a whole parallelogram DG like that, and we're going to call this point H. And we're just going to set out some straight line K, like that. And it doesn't matter what length K is, K can be of any length, but we're going to also have two other straight lines, L and M, such that L is a fourth proportional between BC, CG, and K, so that BC is to CG just as K is to L, which is going to look like that, let's say. And we're going to make that fourth proportional straight line by Proposition 612, of course. And likewise, we're going to have the straight line M as a fourth proportional of DC, CE, and L, so that DC is to CE just as L is to M. Like that. Okay. So again, we're going to do that by 612 again because it's a fourth proportional to three straight lines. Okay. Now, Km, the ratio Km being compounded of the ratios KL and LM, and K being to L just as BC is to CG, and L being to M just as DC is to CE. The ratio K to M is also compounded of the ratios BC to CG just as DC to CE. But BC is to CG just as AC is to CH by 6-1, right? Parallelograms under the same height are to one another as their bases. So BC is to CG just as AC is to CH. But BC being to CG also has K is to L. We have two ratios which are the same to the same ratio, which means by Proposition 511 they are the same with one another, so that the parallelogram AC is to the parallelogram CH, just as the straight line K is to the straight line L. And we can prove in a similar manner that L is to M, just as the parallelogram CH is to the parallelogram CF. That would be rather simple. Again, the two parallelograms CH and CF are under the same height, which means again by 6-1 they are to each other as their bases, which means that DC is to CE just as the parallelogram CH is to the parallelogram CF, but DC is to CE just as L is to M, which means by 511 we have two ratios which are the same with the same ratio, which means that L is to M just as the parallelogram CH is to the parallelogram CF. Now, K being to L, just as the parallelogram AC is to the parallelogram CH, and L being to M, just as the parallelogram CH is to the parallelogram CF, by Proposition 522 xi quali, K is to M just as the parallelogram AC is to the parallelogram CF. So we're going through the common term L with the straight lines K and M, and we're going through the common term parallelogram CH between the parallelograms AC and the parallelogram CF. so that k is to m just as the parallelogram AC is to the parallelogram CF. But it was shown above that the ratio k to m is compounded of the two ratios BC to CG and DC to CE, which means that the ratio to which it is equal, namely the parallelogram AC to the parallelogram CF, that ratio is also compounded of its sides BC to CG and DC to CE. And this is all that we set out to prove, which means we are done with the proposition, therefore, etc. Q, E, D. Now, what exactly Euclid means by compounded ratio is not so much clear in a Greek geometric understanding. But having synthesized algebra and geometry, composition of ratios is merely their multiplication. So, ratios obviously being division. If we take the k divided by L, which is the ratio k to L, and we multiply it by the ratio L to M, this composition, which is just multiplication, is going to be, well, the ratio k to m. So when Euclid says that the ratio k to m is compounded of the two ratios k to L and L to m, you can think of that as the ratio k to m is the product of the two ratios k to L and L to m, which then implies something kind of interesting for parallelograms. And it implies a relationship between the rectangles which compose their sides, and the rectangles contained by their sides, and the parallelograms themselves. Because what we arrive at is that the ratio BC to CG multiplied by the ratio DC to CE, again because composition of ratios is just multiplication. These two ratios, BC to CG and DC to CE, are multiplied by each other. Well, on the one hand, we saw in book 2 and everything since then that rectangles are equivalent to multiplication of the sides which contain them. So in one sense, we can understand this, the composition of the ratios BC to CG and DC to CE to be the same as the ratio of the rectangle contained by BC and DC to the rectangle contained by CG and CE. But on the other hand, this composition of ratios is also equal to the parallelogram to the ratio of the parallelogram AC to the parallelogram CF. And so there's this kind of interesting relationship that if we take these parallelograms and we sort of straighten them out, let's say, the ratio of those rectangles will be the same as the ratio of the parallelograms. But regardless of that being true, because that's not so important, the main takeaway from this proposition is that composition of ratios is, as we would understand it, multiplication of ratios. So anytime composition of ratios comes up, understand it as multiplication of ratios, and that will make any proposition involving it much more understandable, at least in my estimation. Other than that, I've got nothing to say about this proposition, so I'll end the video here and move on to 624.